Hey everyone, a 20-foot ladder slides down a wall at 5 feet per second. At what speed is the bottom sliding out when the top is 10 feet from the floor? And we want this in feet per second. So I sketched a graph, and we are already given that our y, because it's sliding down, a 20-foot ladder, it's sliding down, so our derivative of y with respect to time is going to be -5 because it says it's sliding down a wall at 5 feet per second. All right, it's negative because the ladder is sliding down, and it's customary to make the upward direction positive. Now we want to find derivative of x with respect to t, and this is when y is 10. So when y equals 10 here. So we can find the relationship between x and y here by using the Pythagorean theorem. So what we want to do is go x squared plus y squared equals 20 squared. So we really get x squared plus y squared equals 400. Now, let's take the derivative with respect to t. So if you take the derivative of x, that's going to be 2x, derivative of x with respect to our time, plus 2y with the derivative of y with respect to our time, and derivative of 400 is just 0. You can also divide everything by 2, and that gets rid of the 2. So I'm just going to cross out the 2. Alright, now let's say that we have, we're trying to find dx dt. So first I can write x times dx divided by dt equals -y dy dt. So basically dx dt equals, use a different color here, dx divided by dt equals -y over x dy dt. Alright, so now that we have that, we're going to go back to our Pythagorean theorem and find our x. So if we do that, we get x squared plus y squared. Now our y squared is 10, or our y is 10, and then we know that 20 squared is 400. So we get x squared equals 300, because you do 400 minus 100. And so x equals square root of 300, which is approximately 17.321. Now we're just going to plug it into our equation. So we have x, let me write on this next slide, x dx dt equals -y dy dt. Alright, so just plug everything else in, and you get x is 17.321, derivative of x with respect to time. Our y is going to be 10, but it's going to be negative there. And our derivative of y with respect to t, which was given to us, is -5. So this is going to be 17.321 derivative of x with respect to t, which is equal to 50. And then you just solve by dividing. So that's going to be approximately 2.887. And that's our change of at what speed is the bottom sliding out, which is your x. Thank you. Have a nice day. Bye-bye.